Today we're going to be showing the proof of concept for MIT Lincoln Laboratory. This is the as designed to as planned to as built demo. And we're going to start with a summary of just what the proof of concept demo entails, and then we'll walk through it step by step. On the first slide here, you see that we plan on demoing a fictitious widget design bill of materials, or EBOM, that we have set up in the Aris Innovator environment. It's composed of a front case, a back case, a screw, a steel nut, and a washer. And we've also created a gold nut design part that will support some of the activities that we demo later in the life cycle. Next, we're going to show how we take that design BOM and we create a process plan or assembly procedure for it. The assembly procedure includes a couple of operations, as well as a step or two for each of those operations. And that results in the as planned BOM, or the MBOM, that you see off to the right. That MBOM has one key distinction between it and the design BOM, and that's the inclusion of a phantom part for a kit that represents the front case kit. Sean, if you go to the next slide. Then we'll dialogue through what a parts request and the provision of those parts might look like in order to support a fifth step, which is the creation of an as-built or digital twin bill of materials. Here you'll see that these physical parts in Innovator would represent the real-world parts of the widget, the kit, and all of the components that make up the widget. Included with those are things like the part number that it refers back to on the design side, as well as serial numbers and batch numbers as applicable. Once we have the as-built BOM created, we'll walk through what the RFID technology might do in support of replacing some of those parts within the bill of material. Specifically, maybe replacing the back case with the same part but a different serial number, or replacing the steel nut with a gold nut. Sean, if you can go to the next slide. And then finally, what we'll do is we will take a look at how the physical BOM might be compared to the as planned or MBOM in order to visualize differences between the bills of material versus how something was planned to be built versus how something was actually built. Sean, if you can go ahead and bring up Innovator, we can get started with the detailed steps and demonstration.
There we go.
Okay, so here we are in Aris Innovator. Sean, if you could navigate to the table of contents for us. And let's back out of the physical part menu and go up to the design section, which you already have open. And let's go ahead and click on parts. And let's do a search on our design parts. And Sean, let's go ahead and open up widget, which is the first part listed in your search results. This is the design part that represents the design of the widget assembly. As you can see here, this widget has a number of components down on the BOM tab down below, and is a reflection in Innovator of what we were just showing in these slides. It has 5 components: front case, back case, screw, steel nut, and washer. Sean, if you can navigate back to the TOC, table of contents, come out of parts, and under process, let's go take a look at the process plans. And let's do a search on process plans. Go ahead and open up the widget assembly procedure, which is numbered PP-002. This is a process plan that was created as an assembly procedure for the widget. You'll notice on the Produced Parts tab that we intend to produce the widget part. Sean, could you go to the detailed process plan itself? So here you'll see the details of the process plan as Sean sort of expands each of the operations. You'll notice that we have an operation 10, assemble front case kit, and an operation 20, assemble widget. This is where, as a unit lead, I might be able to take the design BOM as it was released for the widget and incorporate all of the different components into steps and operations in order to plan out how I might actually manufacture and build the widget. And so in this case, you can see the support for the Phantom part P1101, which is the assembly of the front case kit, and the three components that make that up, parts 1101, 9001, and 9003. And Operation 20 represents bringing in the final two components of the design build materials in order to create the final widget assembly. Let's take a look at how this is visualized as an MBOM. Sean, could you go to the MBOM view, which is the next one down on the vertical green bar? And so here you'll see the design parts for the widget, the front case, the screw, the washer, the back case, and the steel nut were all brought in. But the front case kit, which is specific to planning out manufacture, is displayed here directly under the widget in support of the assembly procedure itself and how it was authored. This is the manufacturing view for being able to plan manufacturing for the widget. At this point, what a unit lead or a technician might do is use this view of information to inform how they might request their parts or if parts are even available. So from this, as a technician, I would know that I would want to request a front case kit. I would want to request a back case, and I'd also want to request a steel nut. And so within Innovator, I might take some type of standard automated workflow procedure to indicate those are the parts that I'm requesting, and have that workflow flow to somebody in bonded stores. That individual in bonded stores would receive that request and then know that those parts were parts that they would need to provision in order for planning for the execution of manufacturing for the widget itself. So once bonded stores would be able to provide those parts, the technician would be able to collect those and be able to begin building the actual build of the widget. And in Innovator, that would be supported through items called physical parts and the physical bill of material, which is essentially a digital twin as the product is being built. Sean, could you navigate to the table of contents? And could you go down to the physical parts? And let's do a search on physical parts. So here you'll see we've staged a number of the physical parts as existing individual items, not relating to each other within the system. Sean, could you open up the physical part for the widget? And here what we have is a physical part representing a widget itself, but no physical bill of materials yet created underneath of that. Sean, would you be able to demonstrate how you might use RFID technology in the creation of a digital twin, a physical bill of materials for this widget?
Sure. Let me share my video. All right. Now, I'm going to use this RFID software running on this iPad here to do a few things. So first thing first, we want to add three parts here, physical parts. So we've got a front kit, a front case kit. We've got our back case, and we've got a steel nut. So I'm going to scan those three. Okay, and we've got steel nut, back case, front. Okay, so I'm going to add those parts. And when we refresh over here, we're going to see those three parts.
Fantastic. So what you can see here is the results of Sean's scan integrated directly into Innovator and would support the ability for somebody on the shop floor to use RFID scanning in order to scan the individual parts that they're using to build the product and to actually digitally represent that in the system. Sean, in Innovator, would you be able to go to the menu that looks like a network node just up to the right of the edit button there and be able to open up the structure browser for us? Here, this would give us an actual full view of the multi-level structure of the digital twin. Sean, if you could expand that bottom physical part, the P1101. So here you can see that through the scanning, RFID scanning technology, we actually now have a full digital representation of the real-world widget. Our next use case, though, would maybe represent the desire for somebody on the shop floor, perhaps a technician, finding a need, perhaps something that came out of testing, or as they're going through a build, a need for a deviation. Perhaps some of the parts that we're using didn't end up fitting the need, and it was found during the actual manufacturing execution. Perhaps the back case that we were using, the actual part provisioned to us out of bonded stores, had an issue with it, and we need to replace it with a different back case, which would carry a different serial number. Or perhaps there is something wrong with the steel nut, and we need to replace it with a different type of nut, the gold nut. Sean, would you be able to go back to the widget in Innovator and show us how RFID scanning would be able to support in a situation like that?
Sure. So what we're going to do here is we're going to remove the back case and the front case. So, I'm sorry, the back case and the steel nut. So let me grab those two parts. And got these two parts here. I'm going to scan those. And I've got those two shown on the screen here. So I'm going to hit remove parts. And then we'll refresh this. We should see we only have the front case left. Now, I've gone over here and I've grabbed my new parts, which look like this. And we're going to have a gold nut and a back case that with a different serial and from a different batch. So scanning those right now. And there they are. I'm going to add those parts. And when we refresh, voila.
Great. And what we can see here is now our digital twin has a new back case, new serial number that was installed, as well as a gold nut instead of a steel nut. Sean, would you go up and close the structure browser and then reopen the structure browser so that we can see the refreshed full structure of the digital twin? Yeah, and go ahead and expand that kit one last time. So this is now the new full digital twin as it exists in Innovator. Sean, could you bring up the other windows side by side with this that might help us to visualize how we can use this information to compare it to how we actually planned to build the widget? Great. So here what you'll see on the left with the physical BOM is that you have a digital thread of information for how the actual real-world product exists within the Innovator system. And on the right, you have the MBOM from the process plan, which was as it was planned to be built. And so through all of the digital threads that tie these pieces of information together, you could use your mind's eye to see how you might solution within Innovator a view that allows you to take the physical bill of materials and compare it to the as planned or MBOM in order to see where the deviations might have occurred. And in this case, what we might see is, oh, okay, we intended to use part 9002, a steel nut, but instead in the real structure, what came out of manufacturing was a gold nut at 9005. And so it wouldn't be that far-fetched to also perhaps see or think of the ability to tie some deviation information to specifically why manufacturing took that path that they did. And so it gives you the full closed loop view of everything that went into creating the widget, all the way from its design, all the way to how it was actually built and perhaps shipped. And with that, it concludes our demo on the MIT Lincoln Lab proof of concept for the as designed, as planned, and as built.